Hello everyone, welcome back to Dragonfly Engineering. So this is the follow-up episode to the Game Tamer card rack and tray mold that we started last week or 2 weeks ago. And this week we're going to talk about some additional work on building out the components like drilling ejector plate holes for the ejector pins and mounting these inserts, as well as some accessories for the mold, one of which is this sprue bushing, which was an off-the-shelf item, and then we did some grinding and some EDM work to the end to create a nozzle that we can rotate in the mold to turn on or off injecting the left and right cavity. In some cases we only wanted to mold one part, not both. So we fashioned a custom nozzle out of the off-the-shelf sprue bushing. I think from PCS company is where I bought this from, and it's hard steel. So let's zoom in on this. Okay, so here's one example where we EDM'd a flow channel which allowed only one channel to fill. And this is another sprue bushing which I've got installed, and this particular one has a cross flow so that the plastic comes up through the polished tapered hole here, which starts off on the back of the mold where the injection unit actually engages this hemispherical sealing surface and then squirts plastic through the sprue bushing. And then this surface is what you see here on this two cavity option. And then we can push this one out and then press this sprue bushing in, and then we can just turn on one cavity. So that's the idea. So we'll grind these surfaces, EDM this shape to adjust the flow of the plastic. Yeah, and then we can talk about some pillars that I added to the mold as well to help prevent the main mold block from kind of deforming in from hydraulic force from all the molten plastic pushing on this mold block. You can actually, in some cases, you can actually see like a deformation in this 2-inch thick or 2.5-inch slab of aluminum just from all the force. So a couple of pillar blocks are put on the inside that kind of straddle through the ejector plate, and that will support the center of this block against the bottom base of the mold, which is resting against the platen of the molding machine. So hope you enjoy this part 2 of the mold build, and I'll see you guys next week. Thanks. Okay, let's see if this ground flange fits in our machine pocket. All right, it fits. That's good. So another use of the 5C collet is to stick it into these blocks. So this is the threaded back of the 5C, and then this is the front of the 5C with this flange that I just ground on the surface grinder. And I will loosen it with this spanner wrench. Let's see here. There we go. So I got this locking ring. Then we can pull the 5C collet out, and here's the block that held it. That way we can reference 4 precision sides on a round part, and then pull out our piece that we just ground. There we go. Another use for the 5C collet. So here we're going to cut the beginnings of the runner, and again these runners are going to be selected by that rotating steel sprue insert that we just ground. So I'm going to visually see the depth of this runner. It's not a critical dimension, and this is a runner cutter, so it's like a ball mill with a taper on it. All right, that looks good. I think it's a 1/4-inch end mill, or 1/4-inch diameter on the end face there. So there I'm just scribing a line. Okay, so let's drop down and we will cut our runner end. Make sure we're locked in. doing kind of a big channel because we're going to be filling relatively large parts. So we don't want the plastic to have too much of a chance to cool off with small cross sections of flow. So that should do it. Okay, we're finally starting to get to the beginnings of the assembly of this mold. So this is the A side of the mold base that we were just working on. So these are the two pockets, and then the beginnings of the runner and the sprue bushing hole right there. And still got to clean it up a little. And then here's our off-the-shelf sprue bushing that we modified by grinding two flats in. And now we have, and then what we're going to do is EDM cut a runner similar to the shape that we just machined into the aluminum. This way we've got a selector for the left or the right side of the mold. So shove that guy in, and then our little channel is going to be, flowing this way or that way, depending on how we do it. Of course, it's still a little tight. Let me get my Sharpie marker here. Knock that back out. We do want it tight so we don't get flash and things. So it's probably just a 10,000ths clearance. So over here, this is the backer plate. And you'll notice that there's a machined in groove here. And then this plate basically sisters onto the back of our A-side mold block, like so. And then it bolts in. So you can see this groove at the top. This is where the toe clamps, that clamps this mold into the molding machine, are clamped on. But we're not going to do that. I'm actually going to drill and tap some 1/2" 13 bolts into the back, and then we're going to drive bolts through the A-side platen of the molding machine. So it's a little faster just to have 4 bolts, and I believe more robust and strong for mounting. So, but what we have to do is allow access for the molding machine nozzle to engage with our nozzle port. So we need to machine a hole here. And so I think what I'm going to do is machine a hole slightly bigger than this hole, so that, when this alignment ring is bolted on and we've got a hole through the aluminum, I'll be able to remove this sprue bushing from the back side of the mold through the A side of the molding machine, and then switch this gate from left to right in the mold for part number 1 or part number 2. So the orientation, imagine there's a machined hole that we're going to do next. This plate and alignment ring will be like so, and then this sprue bushing will pierce through all of it, and then I can pull it out, flip it around, changing the direction of the runner, and stick it back in on the fly while the molding machine is on and hot. We can flip from one part to the other. So let's machine a hole right here, bigger than this hole. So here I'm just finding the center of this prefabbed alignment ring hole here. It looks pretty good. So I'll set the 0. And then we're going to use tool number 7, which is a 1/2". So we'll switch tools to that. I'll just visually set this tool height. That's good. So we're also going to do a pilot hole, because we're not going to do a full pocket, we're just going to do a profile. So let's switch to tool number 4, which is a drill. So I'm just picking a random drill bit that's big enough to clear the center kind of web of the end mill there. End mills don't really like to plunge. Even a center cutting end mill, in the exact center of the end mill, there's really no cutting motion. So we just hog it out with the drill. That way we can more easily plunge the tool down. So not as big of a deal with aluminum because aluminum is pretty soft, but steel, you definitely need to pre-drill your mid-mill plunges. All right, so we got that tool set. Again, just visually. All right, I am going to load the program and then we'll cut our circle here. Okay, now we're going to plunge down the center of that hole we drilled. And then cut a slightly over 2-inch circle, or about a, what is it, a 52 millimeter? So I loaded the program to drill and tap the mounting holes for the A side of the mold, and we got this 1/2 inch 13 bottoming tap here. And the holes are not going to go very deep because I don't want to drill into the top of the vise. So I'll chase these holes out and chase out the threaded holes after I pull this thing off the vise. So I got the program loaded, and let's hit the start key. I didn't do a pilot hole on this. This way I can make sure I don't drill through the table of the vise. Actually, I will, so let me stop. These holes are safe, but these may actually nick the vise. So I'm gonna stop the program. I just barely felt the tip break through. So I'm gonna offset this drill bit up by 2 millimeters. Here we go. And I'm gonna offset the tap up by 2 millimeters as well, so that we don't bottom the tap out in a hole and break it. So here we go. And I will rerun the program. That's good. Didn't break off. I'll check to make sure there's thread there. Yep, that's good. So I'm gonna start it again. Okay, I think we are done with the backer plate for the A side of the mold. All right, so we're over on the Haas mill and we're back on the A side deep mold insert for the card holder. And what we need to do is drill and tap mounting holes that line up with the threaded holes in the mold base. So I've got this aircraft drill, which I'm going to use as a drill center. And then we're just going to drill 4 deep holes and then follow through with a counter bore, which I'm going to program while this is drilling. Got some bird nest going on. I can get rid of the bird nest. These holes are for a M5 screw. I had the long M5s here in stock, so I switched it up. I think originally I was going to do 832 threads, but now it's M5. Okay, so now we're gonna machine the counter bores for the mounting screws for these mold inserts. And I'm just gonna do this side first because I've got this really long extended 5/16 end mill, which is approximately 8 millimeters. So I'm going to just do the 4 that have a long reach and then reset this tool to a more reasonable exposure to do the other. But, you know, we'll just do these for now. So I got the program loaded, and I will reduce the rapid, of course, and hit the start button. So there we're spiraling a little bit. The hole we're machining is almost the size of the end mill, so that's why can't really see much. All right, so it looks like we cleared the features of the mold. Okay, so I think we are done with both of these inserts as far as the top side machining and this setup. So we can pull both out. And again, this is dovetailed in. So I need to make sure I don't drop it. Got it in pretty good too. Okay, here we go. Pull these things out. So here's our 2 fixtures, and now I'll saw these in half, and then we got to face off the back side. Pretty cool, huh? Gang mold insert machining. All right, so we're getting close here. So this is the stacked ejector plate. It actually comprises of a top plate, which has a bunch of through holes that the ejector pins string through, and then the bottom plate, which acts as a clamp for the top plate. And we are going to drill all of the through holes that line up with both cavities of the B side of the mold. And then I'm gonna unscrew this thing. And I believe I probably need to pocket out the heads of the ejector pins for this mold so that basically the 2 plates clamp back together. It's gonna be a bunch of little tiny pockets, and I'm gonna pre-drill with pilot with this drill through the first plate and into the bottom plate. And then I'll probably still use the CNC. I may put a vise stop here, and then put this bottom plate back on and then machine little pockets for the heads of the ejector pins. So I got the program loaded, and I'll reduce the feed rate and hit the cycle start button to start drilling our ejector pin pilot holes or lead holes. And we'll do a little coolant. Got a stubby drill, so I don't really need to do the center drilling. But you got to be careful with those stubby drills because your peck distance can't be more than the amount of volume that will pack into the flutes of this short drill. If you pack the flutes full of chips, the new chips have no place to go, so you basically just break the drill off because you've packed it in with a solid chunk of aluminum or drill steel. But it didn't break, so that's good. So I decided not to use the big steel backer plate that I bought to add on to this mold base, the aluminum mold base. And because looking at the model, the B side, actually most of the pocketing for the mold inserts happens on the A side for one thing. And I also realized that I've got room to add some pillars in, and pillars can take the place of an additional steel block. Especially with a cantilevered length of the B side of this mold, you know, the 12 by 16, it seems like it's more efficient to add a steel pillar, a couple of them in the center of the bottom of the mold that supports the B side to prevent the B side from kind of flexing down when we inject plastic into the top of it. So this is some 4340 steel that I actually used for Keith Rucker's Stoker steam engine piston rods. This is a practice piece, so it's a little less than 1.5 inches in diameter. And it's really hard steel, and I think it'll definitely hold up against compression forces to keep the B side of the mold block square, you know, so it can't kind of get bowed down in the middle. But to implement these pillars, which I'm planning on having 2 pillars that go down the center of the mold, I need to machine a couple of holes that are a little bit larger than 1.5 inches, such that the pillar passes through the moving ejector plate, and then we'll tie in the bottom of the mold to the bottom of the back of the B side of the mold block. So I've programmed a couple of just round machining pockets in the ejector plate here so that we can go ahead and cut these and stick and pass them through the ejector plate. So let me run that program and we'll slow it down to start. And these are the 2 ejector plates that are still bolted together. We should have enough retention to hold up against the forces of machining, and we'll do some cooling on this as well. I got a longer flute length end mill so that we can actually pass through this. Okay, we're going to take the final 30 thousandths off this pillar, and I've set the lathe up to do constant surface feed cutting. So we're going to cut 150 feet per minute. So as the tip of this cutting tool goes closer and closer to the center of the part, the faster the RPM will go to maintain that constant surface feed of cutting for the tip. So let's check that out. I'm going to turn the spindle on. I turn on some coolant. Hopefully I don't get too wet. And then we'll bring the tool in and you'll hear the RPM increase as we go to the center. This is 150 surface feet per minute. Make a nice spray. Let me back off so I don't get a shower. Anyway, so that's a constant surface feed cut. So here I'm loading some copper stock, and we are going to machine our profile in the sprue nozzle gate, or the valve that we're creating. So this copper profile is going to be burned into the steel tip of the purchased hard steel sprue nozzle using electric spark erosion. And here in the back I'm just squaring up the back of this insert and putting a threaded hole in it, and we'll screw this copper electrode into a mounting structure that will be attached to the EDM machine. Okay, so we're going to load the EDM tool that we just made to bore out the one-way valve plastic path in this sprue here, or the sprue bushing. So I've got the tool set to change, so you hold on to it. And then we stick the new one in there. It's a different standard, but it works. This is a multi tool chuck, and then bam. Okay, it's in there. Now we're going to move it down to the tool. And of course my microphone died at the EDM machine, so I'll narrate what we're doing here. And basically the EDM is touching the copper to the steel, and it's sensing a closed circuit, and when it sees that there's a short there, then it tells the machine this is the location of the edge of the part. So I'm doing that for the face, the top, the left, and the right, to basically find the part like you would with an edge finder in a mill. It's just closing an electric circuit, since it's an electric discharge machine. And after that's all said and done, then we will then write a quick program to basically plunge this copper electrode down the front face of the hard steel sprue bushing for the mold, and electric sparks will basically just blow away microscopic little beads of metal until it burns all the way down to that center hole, and after which the finishing operation will occur, where the EDM machine will actually push the copper closer to the sidewalls that it burned in the plunge step, and then start to finish out and polish the wall of the flow channel for the hot plastic that we're going to create in this part. All right, so we're ready to burn our shape into our steel nozzle there, and time to go. So I'll hit enter on the run, and the door will rise up, and we will fill this area with oil or dielectric fluid, which is real thin oil, and then we'll start burning the shape with electric spark. Hopefully it doesn't cut you off. Well, it looks like it. Oh, it just barely did. I could probably lower the door some more. So I'm going to halt this, and then we will We got to turn off the run so I can lower the door. Now when the oil passes over, I'll have to refocus again. There's an index of refraction. Oh, gotta spray some. There we go. Let me turn off that light. Okay, let's see if we can see some spark action. I'll turn off all the lights. That may be too dark. Anyway, that's the spark. There you can kind of see. Now it's really going to start cranking. So all those electric sparks are shooting from the copper into the steel and blowing off little chunks of steel. And it would get finer and finer as we go, and then eventually electro polish the surface. The machine bounces up and down to flush out the burned out steel, which looks like just black soot, and it flushes in fresh dielectric oil, and then it repeats. So it's basically pumping in and out fresh oil and pushing out all the sooty little microspheres of steel. Here it's starting to do its finishing of the sidewalls of the cylinder. Yeah, because our electrode is smaller than the final shape that we're burning by about 1 millimeter in diameter. So it's going around and polishing up the sidewalls and making the finish finer and finer as it gets closer and closer to the finished surface. But I'm gonna go have dinner. Okay, we're done with the EDM cutting of our little side channel for our gating sprue insert. Let me lower the door down. Oh, let me turn on it's gonna get a little noisy. And then tank door down. There it is. Let me zoom in on it. There is our channel. I'll pull the electrode up out of the way. And I think we are set for this particular feature. It looks pretty nice. So we're gonna pull this off of the vise and move on to the next step. But there it is. Yeah, EDM machines are nice for machining hard steel, especially complex little shapes like this. All right, let's move on.